We are representing the BEUMER Corporation Airport Division in today's IABSC Summit. Our team consists of Mankish Dave, Monish Badam, and myself, Juan Molina. Terry Gallagher from CLX is mentor for our team. In this year's Young Professionals Challenge, we are presenting our idea on how BHS industry should move forward in the era of COVID. We believe the idea that we are presenting is a different one, but certainly will help the BHS industry to reduce cost and improve reliability of the system. Our idea is to start baggage handling system consulting. Now, we know that this idea doesn't directly address the problems associated with COVID, but as BHS industry, we believe that there are limited choices as to what we can do that have not already been implemented one way or another to address COVID. The name of our company is M2J BHS Consultants, based out of Arlington, Texas, and our services include planning, design, installation, and commissioning of BHS and CBIS for small to large size airports. In this video, we are going to explain what is different about us. We provide lean BHS design specification based on data collection and analysis, which reduce CapEx and OpEx for the system, as you will see later in the next minutes. To meet the customer need by providing optimized lean solutions for BHS is our mission statement. Our team is dedicated for customer success. We put customers' needs and priorities before anything else. Adaptation plays an essential role in the culture of M2J consultants. This means we are always adapting to new technological trends while accommodating the customer needs. The customer is always a priority, and we take pride in saying that we are customer obsessed. For a new business, potential customers are small to large size airports who are looking to adapt new BHS systems or overhaul the existing system for increased reliability and efficiency. Because of our lean design, we certainly present a unique choice to the airports who are looking to reduce their carbon footprint. We provide design specifications based on the data collected at that specific airport. Due to use of common standardized parts, we make a great choice for the airport who are looking for reduced inventories, minimized downtime, and breakdowns in the system. We are constantly adapting to new technologies as they become available, which makes our design specifications and system more efficient with each iteration in the technology. We currently live in the age of data. Everywhere we go, there is data analytics involved in one way or the other. It could be your dieting habits or your commute. It could be your social networking, or it could be your daily shopping. Then why don't we see this data analytics being used more frequently in the BHS industry? We, as BHS consultants, offer this solution to our customer, and that helps get better understanding of the system requirements, future estimates, and system performance. As a BHS consultant, we work with our customer to collect the data on checked baggage characteristics for some fixed amount of time before creating design specifications for that airport. This method ensures that the solutions we are providing matches the customer needs now and in the future, instead of one-size-fits-all solution. If you take time to review some BHS specifications, you will likely notice that most specifications in the last 10 to 15 years match exactly. In many cases, as BHS industry, we lack the use of advanced technologies that we are using in other material handling industries. This is also one of the problems that we address through our design specifications. We look to adapt new technologies in our specification through extensive testing and approval. As mentioned before, through data collection, we provide an option to monitor the system's performance continuously to predict failures. Some of these parameters include temperature, amp draw, false signals from VFD, etc. We prefer to include the BHS system designer in the planning phase with other trays to reduce the design and implementation time and cost of the system. This is an example of using data collection to develop specifications for the airport. Here we can use the checking bag weight at the ticket counter to determine the live load for the system. It also includes giving more freedom to the designer based on their product specification. We see the variable frequency drives being used in the BHS nowadays, but there are still many projects where the DOL motors are being used. There are many advantages of using BFDs in the system, which include but not limited to lower power demands at the start. BFD keep the starting current in the check, which helps in extending the life of the motor. Speed can be controlled by using the BFD, and data collection is yet another benefit. For example, gear motors with a gear ratio of 22:83 used with 8 3/4-inch pulleys can only do 182 feet per minute when used as a DOL motor, but the same gear motor can be used from a speed range of 60 feet per minute up to 210 feet per minute by using BFD. Similarly, a gear motor with gear ratio of 13:38 can only be used at 300 feet per minute as a DOL motor with 8 3/4-inch pulley, but the same motor can be used from 110 feet per minute to 360 feet per minute by using BFD. After consulting with gear motor manufacturer, we have determined that these ranges are perfectly suitable for the BFD operation. This shows an example of using gear motors for some conveyor speed range. With DOL motors, typically we will need 8 combinations of gear motors. However, using BFDs, you can replace these 8 motors with only 3 variations highlighted in green color. There are efficient belts available in the market, which can reduce the belt pull potentially by 50% in some cases. These savings directly correlate to reduced energy consumptions, reduced wear and tear on BHS components. This example shows the typical horsepower requirements with efficiency belting on the left side and traditional belting on the right side of the screen. As you can see, in many cases, the total horsepower required is dropped by half. This chart only uses the standard horsepower of 1, 2, 3, 5, and 7.5. In the VHS industry, IE2 and IE3 motors have been used widely in the past 10 years. The gear motor technology, however, has been moving forward with IE4 and IE5 standards. Some of these motors offer 50% less energy losses compared to IE2 motors. Now, the use of these motors will additional capital cost, but this cost can be recuperated within the first years of the system operation due to energy savings. Our analysis of 2 BHS projects show that additional expenditure can be recuperated within the first year of operation. This is the example based on a real BHS project where we analyze the system based on the existing system design and specifications and modify the system design and specifications. The modifications to the systems were made on the change in horsepower and belt pull limitations. As you can see, the total number of drive count for transport conveyors went down 13% cumulatively. The total number of count for mid-drives went down by 573%, and the number of end drives and queues went up by 69% and 8% respectively. Based on the cost analysis on the right side of the screen, you can see the total cost savings for transport conveyors is 17%. Due to reduced number of drives, the total cost of IE3 gear motors with BFD results in net savings of 10% in gear motor costs. Due to redesign and optimize systems, the total power requirement is reduced by approximately 33%. The energy cost savings reflect the potential savings of $3.9 million with IE3 motors, based on the energy rates provided by the U.S. Energy Information Administration. With IE4 motors, there are additional expenditure of $152,000, but that is covered in the first year of operations and results in additional savings of $200,000 over a 10-year period. This is yet another example. As you can see, the total number of drive counts for transport conveyors went down 15% cumulatively. The total number of counts for mid-drives went down by 346%, and the number of end drives and queues went up by 50% and 3% respectively. Based on the cost analysis on the right side of the screen, you can see the total cost savings for transport conveyors is 23%. Due to reduced number of drives, the total cost of IE3 gear motors with VFDs results in net savings of 14% in gear motor costs. Due to redesign and optimized systems, the total power requirement is reduced by approximately 37%. The energy cost savings reflect the potential savings of $980,000 with IE3 motors based on the energy rates provided by the U.S. Energy Information Administration. With IE4 motors, there is additional expenditure of $8,000, but that is recovered in the first year of operations and results in additional savings of $25,000 over a 10-year period.
One of the biggest concerns we hear in the IABSC often and loudly is the cost and pain when the system is down. Our suggestion is using IoT in maintenance. As stated in the article, using IoT for predictive maintenance isn't a panacea. It was discussed at length the advantages of IoT in maintenance by Mr. Sam Bakota in the latest blogs on IABSC website. There are primarily three types of maintenance being done right now: preventive, run to failure, and condition-based maintenance, but each of them have their own sets of issues. For instance, preventive maintenance. Maintenance schedules are based on the estimate of how long the average electric motor runs. To be on the safe side and avoid complete motor failure, maintenance usually occurs too early, and well-functioning parts may be replaced. Even so, there's still no guarantee that a new problem won't occur shortly after maintenance takes place. The second one is run-to-failure maintenance. This approach waits to do maintenance until the machine stops working. This typically results in full motor replacement, because repairing a rundown electric motor on the spot usually isn't a simple task. The last one is condition-based maintenance. Before electric motors go down, they generally start to show irregularities, like noise, imbalance, drag, etc. In a condition-based approach, a maintenance specialist goes to every electric motor and listens to it with an appropriate tools. But much like the doctor with a stethoscope, depending on the environment, this may be an easy job or difficult, and even dangerous sometimes. And of course, the doctor can be everywhere at once. Despite its drawbacks, preventive maintenance is probably better and more cost-effective than the run-to-failure alternative, but condition-based may be a better option, especially when you bring in the IoT. Monitoring belt conveyor systems used to be performed by means of inspectors and offline. These days, the developments are towards fully automated inspection systems. The IoT enables that more information from sensor systems becomes available that was not available in the past. Theoretically, this means that monitoring belt conveyor systems 24/7 should become a reality, and downtime and unexpected maintenance a thing of the past. In conclusion, there is a huge market potential for the BHS industry to evolve into the 21st century while giving savings and more reliable systems to the clients. M2J BHS Consultants, being the lean fighting machine, would be the most fitting prospect to bring this to fruition. Our focus and core competencies help achieve the IABSC objectives.